Hi everyone! Today's video is going to give you a strategy for how to compare place values. But before we get into comparing any numbers, let's do a quick review of some basics of place value that can help us. Remember, in math, it's always helpful to look for patterns. And when I'm looking at this place value chart, I notice a couple patterns right away. First, I have three columns grouped together to make four different colored blocks. In other words, I have three columns in the yellow block, three columns in the green block, three columns in the blue block, and three columns in the purple block. Hopefully you remember that in math, when we group three digits together, we call this a period. So the yellow block is really representing the ones period. The green block is representing the thousands period. The blue block is representing the millions period. And finally, the purple block is representing the billions period. And within each of those blocks or periods, we have another pattern that we can recognize. And that is that the digits going from least to greatest value follow the pattern ones, tens, hundreds. So in the ones period, that simply goes ones, tens, hundreds. But in the thousands period, that means we have 1,000s, 10,000s, 100,000s. In the millions period, we have 1 millions, 10 millions, then 100 millions. And in the billions period, we have 1 billions, 10 billions, and 100 billions. That pattern is going to be really helpful as we start to compare different digits. So let's take a look at how that is important. We know that a digit in the thousands place is not worth the same as a digit in the millions place. So for example, let's say I put the digit 8 in both the thousands and the millions place. I know that the 8 in the thousands place has a value of 8,000, but the 8 in the millions place has a value of 8 million. Even though I used the same digit, an 8, the values are very different and represent different numbers. So let's start comparing and see how this is important for us. Let's take a look at the number 44. The 4 in the ones place is worth 4. But the 4 in the tens place is no longer worth 4. Now it represents 4 tens, or 40. So if I'm comparing, that means that the 4 in the tens place is how many times as big as the 4 in the ones place? Think about this for a few seconds. Okay, do you have a prediction? Let's take a look at another example and see if your prediction holds true. This time, let's take a look at the number 3,329. The 3 in the hundreds place is worth 300. The 3 in the thousands place is worth 3,000. So let's compare. The 3 in the thousands place is how many times as big as the 3 in the hundreds place? Take a second to think about that. Are you starting to notice a pattern? Let's look at one more and see if you can figure out what's happening. This time, let's look at the number 664,102. I have a 6 in the hundred thousands place, which I know is worth 600,000. I have a 6 in the 10,000s place, which I know is worth 60,000. So let's compare. The 6 in the 100,000s place is how many times as big as the 6 in the 10,000s place? Did you find a pattern? Every time we move one place value position to the left, the value of the digit is multiplied by 10. So when 4 became 40, we moved from the ones place to the tens place, that's one position to the left, and we multiplied by 10. When 300 became 3,000, we moved from the hundreds place to the thousands place. That's one position to the left. And finally, when we went from 60,000 to 600,000, we moved from the 10,000s place to the 100,000s place by one position. Each time, we multiplied by 10, because in our place value system, each place value position, as we move to the left, gets multiplied by 10. So what do you think might happen if we move 2 places to the left? This time, let's take a look at 70,000 becoming 7 million. Now we're shifting not just one, but two places. This time we're multiplying by 100 because we would multiply by 10 to get from 10,000s to 100,000s, and then by 10 again to get from 100,000s to millions. So we can use a strategy to help us solve questions that ask us to compare digits. So let's take a look back at the eights and imagine that they're in the number 8,628,034. To compare, we're going to line up the numbers matching up the place value positions. So I knew that the 8 in the thousands place was worth 8,000 and the 8 in the millions place was worth 8 million. Now I can cross off the place value positions they have in common. In this case, that's the ones place, the tens place, the hundreds place, and the thousands place. I'm left with 3 digits, which represent moving 3 place value positions. Since there are 3 digits that don't have a pair or a buddy, that means that 8 million is 1,000 times as big as 8,000 because moving 3 spaces, 1, 2, 3, multiplies by 10 3 times. This is times 10, then times 10 again, then times 10 one more time, which is 1,000. And you can think that 3 place value positions means 3 zeros. All right, so that's moving to the left. Let's take a look at what happens when we move to the right. Let's look at the number 44 one more time. We knew the 4 in the ones place was worth 4, the 4 in the tens place was worth 40, but now the 4 in the ones place is how many times as big as the 4 in the tens place? This time we're moving a different direction. Do you have a prediction? All right, let's look at another example. Let's look again at 3,329. The 3 in the hundreds place was worth 300. The 3 in the thousands place was worth 3,000. So now the 3 in the hundreds place is what relationship as big as the 3 in the thousands place? All right, let's look at one more and see if your prediction holds true. Again, let's go back to 664,102. The 6 in the hundred thousands place was 600,000. The 6 in the 10,000s place was 60,000. So let's compare. The 6 in the 10,000s place is what amount as big as the 6 in the 100,000s place? Well, this time it's a little trickier to talk about it with multiplication because our numbers are getting lesser. So hopefully you found a pattern though that every time we move one place value position to the right, the value of the digit is divided by 10. We could also say that our larger number is being multiplied by 1/10. We're going to talk lots more about this when we get into fractions, but dividing by 10 is the same thing as multiplying by the fraction 1/10. So 40 went to 4 by moving one place value position to the right. 3,000 became 300 with one place value position to the right. And 600,000 became 60,000 by moving one place value position to the right. Each time we multiplied by 1/10, which is the same thing as dividing by the whole number 10. So again, what do you think happens if we move two place value positions to the left? For example, going from 7 million to 70,000. Just like last time, we are changing with 100, but this time we're dividing by 100 or multiplying by the fraction 1/100th. Again, we can use that same strategy. So let's imagine those 8s back in that number, 8,628,034. We're still going to line up the matching place value positions, but this time our 8 million is going to be on the top. We'll still cross off the digits that they have in common, and we still see that we are moving 3 place value positions. But this time, since we're moving 3 place value positions to the right, that means that we are 1/1000th as big as 8 million. So moving to the right just takes that power of 10 and turns it into a fractional amount. 3 place value positions still means 3 zeros. It just now becomes part of our denominator. All right, so when was the last time someone asked me to compare numbers and why should you care? Great question. This is how you might see this particular skill in real life. Our base value system, or our place value system, is based on a base 10 system. That means every place value position relates to the one before and after it by either increasing, getting bigger, or decreasing, getting smaller by a power of 10. Remember, a power of 10 is a number where the 10 is multiplied by itself a certain number of times. So our examples of that are 1, 10, 100, 1,000, or 1/10, 1 100th, 1 1,000th, and so on. So using powers of 10 makes it easy to do mental math and save some time. So for example, if we want to multiply 60 by 100, I know that I have my number 60. I know my answer is going to be greater because I'm multiplying by a whole number power of 10, 100. And I know my first digit is going to be sliding to the left because if I'm getting greater, I need to move those digits to the left. So using powers of 10 makes it easy to save some time. I'm starting with that 60 again, multiplying by 100 moves 2 places to the left. I can fill in my empty spaces with placeholder zeros to give me an answer of 6,000. And in the real world, you might see this in word problems or scenarios like this. Sports Fairy is buying t-shirts for school spirit days. Each t-shirt will cost $8. If they plan to buy 1,000 t-shirts, how much will it cost the school? Or Maria is making bracelets to sell with her friends. Each bracelet will use 15 inches of yarn. If she wants to make and sell 100 bracelets, how much yarn in inches will she need? Examples of becoming less would be something like it takes Anna 60 seconds to run a short race in PE. It takes Olympian Usain Bolt 1/10 of that time to run the same distance. How long does it take Usain Bolt to run the short distance race? Or John is building a model of the Eiffel Tower for a project about France. The Eiffel Tower is around 900 feet tall. John wants his model to be 1/100th of the actual tower. How tall will his model be? So these are scenarios we'll be looking at together because this idea is kind of tricky. It seems pretty easy on the surface, but it can be hard to recognize in word problems. So we'll do lots of guided examples together throughout our year, but the big idea is that each place value position relates to the one before or after it by a power of 10. Thank you for tuning in. I hope this video was helpful.